Sir, to give us a great opportunity to conduct the FDP on artificial intelligence and neural networks. And I would like to thank Dr. Manju ma'am, Head of the Technology Centers, and Mr. Nao Subramani sir, Professor of CSE Department, Mrs. Premalada, Head of Computer Science and Engineering
Technology
Department,
sectors and
and
Mr.
Mr.
Nao
Vis,
Subramani sir, Professor of CSE Department, Ms.
Professor of CSE Department, and Mrs. Premalada, HOD of CSE Department, and Mr. Veslin Sir, HOD of IT Department, to motivate and encourage us to conduct the FTP. Finally, I would like to thank my friend and colleague Mrs. Kamakshi ma'am as a coordinator to support in all ways. Now we will come to the topic. Artificial intelligence, also called as machine intelligence. How the machines can take the decision like human, it's a very great wondering to all. It is a nowadays it is a very blooming and current technology also. So only we have chosen this FTP as artificial intelligence and neural networks. So before entering to introduce the resource person, I first just explain the schedule of FDP. Day 1, introduction to artificial intelligence. Day 2, computational intelligence and neural networks. Day 3, Python programming in AI. Day 4, recent AI trends for automation. Day 5, importance of student motivations in academics. Now, I welcome the resource person, Dr. Poonkavithai ma'am, Head of Operations in B2 Technologies, Chennai. She has completed her PhD in Pondicherry University, Pondicherry. She has completed in UG there also. She has more than 11 years of experience in IT field and 6 years of experience in teaching field. She achieved 2 times Testing Star Best Innovator Awards in CTS IT industry and published 2 books related to Python and C programming. She has published many international journal papers and also have presented national and international conferences. Now I invite the resource person, Dr. Poonkavithai ma'am, to present her valuable speech. Thank you. One more information to the participants, all of you. Whatever the informations, you can type it in a comment. We can see, and based on it, we can give the answer to you. Thank you.
Okay. Am I audible? Can somebody tell me if I'm audible or not? Am I audible? Hello? Hello? Am I audible? Hello? Am I audible? Somebody is saying you're muted. Somebody is saying audible. Dr. Satish, am I audible now? Okay. First of all, thanks to Shankari for introducing me in a real nice way. And thanks for the opportunity. Thanks to the management for the opportunity. So, should I say it's a good thing or bad thing? I don't know. My system got crashed just half an hour before. I was just checking the PPT I prepared, and it got crashed. So as of now, okay, I'm going to use some other PPT that I have prepared for some other event. Okay, before moving ahead, believe the communication would be only through chat, if I'm not wrong. So the participants cannot speak. Am I right? I like this person, Mr. Satish. He's the only person responding quickly to me. So yeah, Mr. Satish. Can you tell me? Am I audible? So you reply only to that question, is it? Am I audible? Okay. So spontaneously you gave me an answer, yes. Only for the question, am I audible? Okay. So I also see Vijay Nirmala. I also see Dr. Bharat. I also see Dr. Mamta, who are really nice to respond. See, in the era of this virtual FDPs, it's very difficult to communicate. Most of the time the sessions are like you have a ppt, you just walk through it, and literally you're talking to your own system. And a funny thing is you watch yourself, you see your face expressions and watch yourself, and you're talking to yourself most of the time. Okay, so uh, without any further delay, I'll just jump into the topic. So I'm going to ask you all few questions. Okay. So like Dr. Mamta, Dr. Satish, and the others, I want you people to respond. Okay, quickly, so that we can have a very good discussion. Yeah. Okay. So why do you think there is this much of buzz around AI? Rather, let me put it in a different way. Is there any application that you have used, be it mobile app or web app, or anything that uses AI in your daily life? Is there anything? See, without we talking to each other, we are not going to get anything, gain anything. So please do answer. Otherwise, it's going to be very boring. So seems like the participants need the conventional sharing the PPT. I'm just going about it. Okay. So what I'll do, I'm not going to go the conventional way. It is to introduce AI and then move on. Most of you would have heard about this term, Industry 4.0. Anybody who has not heard about it, Industry 4.0? Okay, no answers. So what I'll do, I'll just share my screen. Yeah, screen share and move ahead with presenting a topic that I had already spoken elsewhere. Okay. So instead of moving ahead with introducing AI, which most of us would know what is AI, what is artificial intelligence, ever since way back 90s, 1990s itself, which there was a big um, there wasn't a big bus, but we all knew there was a course on AI, and everybody studied AI in their engineering. So I'm not going to dwell on that part. Okay. So introducing something that we already know is going to be not going to be very interesting, is what I understand. So I'm going to move ahead and give you a glimpse about cyber physical systems that are going to rule. Okay, that are going to rule the industry in every domain possible, be it healthcare, be it retail, be it manufacturing, be it what. in every sector, every domain, you're going to see cyber physical systems. And these physical systems are going to have AI as a component. Okay, so what are these cyber physical systems? So, for us to understand, cyber physical systems are the systems which are very strong in communicating, um, computation, and the strongest component here is the network. Okay, via the network, actions are being taken, and the actions are on physical systems. Okay, so to be very easily, if you could understand, physical cyber physical system could be a system wherein a doctor from Norway operates a patient in India, Chennai, okay, from Norway itself. Okay, this is something via the network. So that's the power of cyber physical system. Now somebody can ask, why AI in cyber physical system? Without AI, okay, without AI, without IoT, cyber physical system is going to be very it's like it is a big ocean. Cyber physical systems are a big ocean wherein AI, IoT are going to play a very major role. Okay, without these two, cyber physical systems will never exist. So our communication, control, and computing power. If these three make it all happen, make a cyber physical system um, complete. Okay, the system could be physical, biological, or engineered. Could be any of this type. Okay, and the operations, it's not integrated or monitored or controlled. The operations has to be integrated, monitored, and controlled. That's the way cyber physical systems work. Yeah, and this is one example I picked up on how you know in a manufacturing unit of any car, be it Nokia, sorry, not Nokia. I went on to think about it. So Hyundai, okay, uh, Ford, be it any car, any. So what happens is, in workstation one, the most basic structure gets built, and then it moves on. Each part that's going to make up or build the car could be added. If you could see this diagram, you could see that the base was ready in workstation one, and then you had uh, other components getting added, like wheel in the third workstation and the next wheel in the fourth workstation, and it goes on. That's how cars get manufactured, simply to put on in a sequential order. But how could we do it in a faster way? Okay, that is where our CPS are nothing but cyber physical systems. So if you could see here, you can do lots of um, integration. Okay, and you can make things happen in a parallel way and get things done in a much faster way. So this is, and this is what is needed when we want things to get into the market in shorter time. Okay, so here this is where we have this CPS. So when we split the entire what is cyber physical system, so why it has the name cyber. Most of the people take cyber physical systems to be as closely connected to cyber security, mainly because of the term cyber. Okay, and cyber security, cyber crime, cyber physical systems, they put all these into one particular domain. But please be informed, cyber physical systems are by themselves a separate branch. Okay, and also be informed that cyber security would be a part, a chunk in cyber physical systems. Okay, so, cyber, as the name suggests, it's been coined only to emphasize on the three C's, which are computation, communication, and control. Okay, and physical is more to do with, you know, you'll have to understand. Though we are talking about cyber, we're not talking about anything to do about a computer here. Okay, that is why we have brought in the term physical. Why? Because there is going to be a component which is which on which cyber is being integrated. That's the main crux of cyber physical systems. Okay, so in no way a computer as such is going to be connected. And again, why this is connected to Industry 4 is, ever since IoT saw a boom with smart. Okay, IoT has more to do about sensors and actuators and connecting the object, any object, through internet. It stops there. But cyber physical systems goes a step ahead. Okay, so a step ahead, and it is all about making a decision from the computation, from whatever communication was done, and control the system, physical system. Okay, so after saying that, so why we start all this cyber physical systems? Okay, major benefit is uh, shorter time to market. Next is the cost involved. Okay, cost involved is majorly reduced, and excuse me, and the efficiency of the systems is multifold. So this is why we use a cyber physical system. Okay, uh, so this again we emphasize on why we use a cyber physical system. Mainly because the interaction between the computational source. Mostly again, when you bring in computation, okay, there every human being tends to think about a system, or a laptop or a server. It goes like this. Okay, max. Some people who are into networking might think about a switch, router, hub, or whatever. Okay, the computation uh, and communication. Sorry. So here we are thinking more in lines of sensing and doing some action about on the sensed data. That's the most important thing. So I had been talking about Industry 4.0. What does this say? Interestingly, Industry 4.0 is most emphasis has been given to cyber physical systems. So, which means business ahead, okay? Whatever business ahead that's going to evolve would be based on these six principles. So what are the six principles? Interoperability. The interoperability is nothing but you're having several smart gadgets, okay? Smart things, smart TV, smart whatnot, smart home. You have several smart. Here we are moving ahead since it's about the industry. We are aiming at smart factories, okay? So which we intend to connect and get things done through Internet of Things. So this is why I'm saying IoT is part of cyber system and virtualization. So I started out with an example: a doctor from Norway get operating company in Chennai. So how would he do? Everything is visually. Um, the physical body is not there. So virtually he does it, and the virtualization is converted into the action. Okay, that's how we do. And decentralization. Okay, so you could someday be as head of manufacturing unit. You can start the uh, manufacturing of one particular lot from somewhere, anywhere in the globe. Okay, so you can do operate the entire factory from anywhere. That's the decentralization and real time capability is. So you start the manufacturing of one lot. So how will you know things are happening? So in the real time, whatever is happening is the data is analyzed, the data is you know which could be visualized by you at any time. Okay? And service orientation is like, if we are stuck, we should be stuck with the services that we would be giving, not on very simple things. Okay, like service orientation, as I picked the example here, completing the lot of cars. Okay, clarity is very very important when it's like you're you have started a lot. However, how well you can utilize the resources that are there in the factory. Okay, so how can you split up the work and give it in small chunks? Is about modularity. So these are the major um, sectors that are going to get hit by. It's not hit. Industry 4.0 standards are going to focus more on these nine areas. The nine areas are, as the name suggests, advanced robotics, addictive manufacturing, augmented reality, simulation, horizontal vertical integration, industrial internet, cloud, cyber security, big data, and analytics. So, if you could say big data and analytics, here your AI is going to play a part. So, all these are going to be put to, yeah, I can't say put together. Not all business scenarios would need all these nine. It could be one and two, four, five, six, seven, whatever. So all these uh, would come together appropriately and get a business solution realized. Okay. So we have been talking about physical systems, and I said it's not a computer. So most, and I was talking about smart, and most of you would have thought about some embedded system that's coming into place. So what is the difference between these two? Okay, embedded system is just, if an information is given, that information is processed, and on processing it just the sum. Okay. Here in cyber physical system, it's a complete. If you could imagine, it's like n number of embedded systems put together, and there is a decision making module, there is a computational power, all put together would become a cyber physical system. So um, again, in cyber physical system, embedded system is just a part. So what are things that are involved in a CPS? Everything about engineering: control theory, electrical and electronic design, AI, modeling and verification, software programming, mechanical engineering, ubiquitous computing. So many disciplines are going to get involved. So if you are a computer science engineer or doctorate, or a professor, okay, it's high time we start looking at what actually is an electrical engineer doing. Okay, it's high time that you start thinking about how a robotics engineer and mechanical doing. Okay, what does he do? How does he understand um, how to build an engine? Whatever, all these you will have to start thinking. And so, as always, more to. So these are the components of CPS. So important component would be the physical environment. I told a couple of slides before, it could be physical system, could be biological, or it could be an electrical electronic device, anything. And sensors and actuators, the sensors are what, from the physical environment, it pulls out the data, and the information processing analyzes what is needed, and according to the need, the actuators acts upon the physical environment. That's the crux of CPS. Okay, so this this act I've given in a different flavor. Uh, Types of components. Okay, so physical components, software components, and connectivity. Without connectivity, there isn't CPS at all. So it's a gateway. It could be you know anything that is going to bring in a communication between the physical components, and software components are embedded softwares. Okay, to embedded softwares and software components is mainly on the how the actuators, the feed it has to give to the physical systems. What are the characteristics of CPS? They are reactive. Okay, why reactive? So, as the as I was saying earlier, uh, physical environment gives some data, and that data is processed, and for that processed data, there is an output. That output is fed back to the um, physical environment. So it reacts every time there is a reaction, and it is hybrid. Why it is hybrid is, so you could relate, very much relate with a guy operating, a doctor operating the patient in India. Okay, so here we are talking about the physical environment being a human being, and there is also, the system could be a normal electrical appliance, the system could be anything. Okay, so a huge kiosk may be for anything. Okay, so the system is actually hybrid. Okay, so dynamic. Why? Because see, after the actuators give a set of actions for the physical environment, the environment changes, and again the sensors send some data to process. So it's keeping on changing. Okay, I think I repeated one particular slide. Challenges in CPS. Okay, it's very complex actually. Okay, very complex, and the amount of um, flexibility and the amount of dynamic inputs and outputs that you're visualizing is going to be very huge. So it's just complex. So So I think I have also said about dynamic environment, and you have to keep uh, sending the information about the physical system, you know, frequently, very frequently. When you're doing this very frequently, the amount of data involved, it becomes huge. And when you're talking about communication, you're talking about the risks of communicating sensitive data. So all these has to be, thought through. Okay. So what kind of expectations do we have when we think about CPS? Uh, Definitely, if not CPS, any system has to be, we should be able to depend on it. It should be efficient and meet all the requirements, and the properties of the physical environment, whatever it needs, uh, are all those really good enough to uh, take up the actuators output and give the input to the sensor. So all these has to be. So dependability um, could be gauged. Okay, gauged by using these matrices: reliability, dependability, availability, safety, and security. So all these terms are pretty straightforward. Okay, so I'm not going to dwell further on this. And efficiency is like, again, efficiency has um, different flavors. All these flavors has to be intact to have a very good CPS. Okay, so it has to be from the software end. The software must be um, optimal. The software must not be taking too much of time or space. It has to have a cost and energy efficiency. This comes into picture when hardware and software are considered. Weight and runtime are, again, see, the physical environment, which is, let's say, a machine or a device. Okay, so when the device is there, where you're not supposed to have or give a CPS which is looking big, or it's going to occupy your entire budget. No, right? So it has to be in a very very simple and effective manner. So real time constraints, what could be the real time constraints? Yeah, the dynamicity. Okay, I'm not the dynamic environment, the physical environment. It has to react properly, and it also has to uh, give back the reaction it has got. All this has to be captured in a very, very quick and effective manner. That's the real time constraint. So we'll come to the different levels of CPS. Okay. So in these levels, okay, where could AI come into picture? Would be the cognition. Cognition is where AI would be figuring out in CPS. So it helps in decision making. Okay, the configure cyber configure is on software end. Cyber conversion and connection all are on the physical hardware part of the CPS. So Uh, is there a way to see the comments? I could see only my slides. Okay, so I thought I'll stop here to check out if you're having anything. So, is, are we going in a right way? Am I making sense to you all? Dr. Rajendra, am I making sense? Nice to see somebody from Nellore. Okay. And Sastra University also, Sri Lakshmi. Seems like, we have all got used to not responding in an online uh, FTP. Sometimes it looks, Sri Lakshmi, that's nice to see you respond. Thank you. Okay, I'll proceed further. Yeah. Sometimes I think nobody is actually listening. Yeah, maybe Satish sir um, has gone back to do something important. Okay, so I start again. Connection is three ways you can do connection: plug and play. You can have a communication which is wireless. You can have a sensor network. Okay, and I've tried to explain all these. Since these are not um, a more AI focused, I'm going to just skip all those and just go to cognition. So cognition is what we love to focus more on. So integrated simulation and synthesis, remote visualization of human, collaborative diagnostics and decision. All these three, we'll have AI playing a very, very, very vital role. Okay, so this is all about cyber physical systems. So if you check what are the applications for cyber physical systems, you could see lots. Okay, healthcare, infrastructure, energy, communication, so many things. And what does cyber physical systems require? They require definitely cybersecurity. Why? Because when you're dealing with sensitive data, you need cybersecurity in place. And what else does a physical system need is you have to design something which will uh, give better scalability, better complexity management, and okay, also you can make your uh, system which is interoperable, have a very good computation in place. Okay, this cyber physical systems could also be uh, are they are in fact control systems. Control systems. It's not that it should have a human in the loop. It can work without a human also. Okay, the main thing about the control system is it's intelligent and adaptive and predictive. These two areas are where you will have your AI come into place. Okay, so what are the examples? Examples are smart grid, autonomous automobile systems, medical monitoring, industrial control systems, robotics, and automatic pilot avionics. Okay. Is there any of, if you could just think about all these applications, okay? Is there any application that can work without AI? No. Okay. So, we have been talking about IoT, CPS, both. Okay. So, mm, it's, when you talk more about CPS, you might tend to misunderstand that IoT and CPS are the same. Okay. This particular slide was placed to clear that out. Okay. So IoT is only for mo- from the sensors. It does an analytics. It does do a little bit of monitoring. Okay, and after doing the analytics, it does do an action also. We don't deny that, but it is all on focused on connecting the whatever device you're using through internet. That's it. You're trying to connect two pieces or two devices. That's it. Here in CPS, it becomes bigger, mainly because uh, it involves lots of decision making. Okay, so it is like it has to have enough of intelligence to do reasoning, to do a planning and act upon it. Okay, so it's more on to uh, having a holistic, huge, complex system. Okay, so we are done with cyber physical systems. So how do we get into AI? This is one picture which you can um, get in Kaggle. Kaggle is something like, if you are a person who's going to research on machine learning, okay. Uh, if you are a CSC person, by now every student in your class would know about what is code check, what is hacker rank. Students would know what is hacker earth. All these, okay, all these are coding platforms. So we have something called Kaggle, which is powered by Okay, Kaggle is one platform wherein you can pull out data sets, you can attend competitions, you can write blogs called notebooks in Kaggle. Okay, A- which is pertaining to only AI. See, you could also see AI hackathons or AI code competitions in Hacker Earth or Hacker Rank also. But if you want a complete repository, you can go in for Kaggle, and there is one more analytical here. Okay, these are the very famous. Okay, you could hardly see maybe one or two more, but these two, if you are able to follow religiously, I would say you can definitely rock as a researcher. Okay, so coming back to what is AI, and so we all have been talking about AI a lot and machine learning uh, lot before. AI was spoken about lot even before we came. Machine learning came into became a buzzword very recently. Recently, maybe in 10 years, okay, 10 to 15 years. AI was even more. It dates predates. Okay, so AI's power became even more powerful with the machine learning algorithms. Okay, and it became even more powerful when you considered when you moved on to deep learning. When we don't have a target, okay, but we want to do something with the data, and most all these, okay, all these chunks became very famous mainly because of big data, and data is huge. Okay, we'll have to do something with the data, right? There is a term which there is a quote which says, data science is like oil. Okay, um, you'll have to use it. Okay, then you'll have to use the data properly, make it, put it in your car or put it in your bike, drive it, enjoy it. Okay, you cannot just have the oil, right? So you'll have to use the data that's there out there, in be it in your company, be it in your educational sector, anywhere. Okay, you have to use the data. When machine learning was about, what is your target, and you're going to predict or you're going to classify. You already know a cat is a cat, apple is an apple. Fine. When you're having a lot of things, okay, car and bike and bicycle, all these are put together, and you want your system to identify what is the car, which is the car, which is the bicycle. Then you go in for your uh, deep learning. Okay, when you don't have a proper set of features to understand. Okay, so data science is all put together. Uh, Please do not uh, get carried away by if somebody is saying I'm a data scientist. It means that the person has to uh, understand the correlation between deep learning, machine learning, and AI. Okay, if somebody says I can work on linear regression, okay, SVM, K means he is pretty much a machine learning guy. He has not ventured into artificial intelligence. Okay, so when you are building something, when you are talking only about the algorithms, modeling, fitting, transform, all these you are only in machine learning. When you are putting all this in place as a product, as an application to work on, to react on something, then only you are uh, maturing to AI. Okay, so why AI in CPS? You anything that is going to be smart, let me tell you, anything that's going to be smart needs decision making. Anything that needs a decision making on something historical, something huge, you're going to land up in machine learning. Okay, so here this is where your AI comes into CPS. Okay, now now gone are the days we are talking about, only AI is now evolving into different things. Okay, so it's like a very easy example would be Oops. Okay, Oops started out with C, C++, and we would be having anything. Oops is the same. Okay, it's the concept. Okay. Similarly, from AI, you would be getting lots of other things wherein there would be slight variations, and artificial intelligence concept would be applied appropriately. So, edge AI is something that focuses on a hardware, okay, in place, and machine learning algorithms are being used. That's edge AI. One another thing that you will have to understand is the device need not be connected to internet at all. Okay, but how this happens is how the CPS is designed. Okay, so uh, here in edge AI, cloud computing power is put into place so that you can reduce lots of communication costs. Okay, and that's about and edge based systems. So rightly I spoke about remote robotic surgery. Okay, somebody a doctor from elsewhere can operate somebody in India or anywhere else. So rescue operations, wherein um, you can set uh, sensors in every place wherein you uh, are possibly thinking about theft or something going to happen. Those sensor could send inputs, and you can trigger on the rescue operations. Self-driving cars, autonomous cars, all these are serious and edge. Okay, why do you need all this? Okay, mainly to reduce the cost. Okay, reduce the cost and improve the efficiency. That's all, nothing beyond this. So how AI enabled cyber physical system would look like, the interaction between all these physical systems and the data which we have is going to become smarter. Okay. So how are we deal with the complexity that's being built up because of introduction of AI? This is how generally a CPS system would look like, architecture. So here we have huge data that's being processed, and we have data mining concepts that would convert any information into some understandable, reactable knowledge. Okay, so you have several validation that happens after processing is being done. The data is fed for further analysis and you know to the system to get inferences and act upon the inferences. Okay, so this is how the input given is converted into output. Generally, a model driven approach is taken up in CPS. So, where actually, in which layer actually AI comes into place? So, I've been repeatedly saying decision making, and any decision making when data is huge, you have AI. Okay, so this is how these are the three layers in which CPS acts upon. So we'll come to few examples. Before that, I'll just check if anybody is having. So all well, guys. All well. So far, fine. So we'll see few of the examples. Yeah, on CPS. So let me go ahead and show you few examples. So this is one very interesting example. Okay, you have lots of robots which are actually doing the surveillance, keeping on doing the surveillance. Okay, um, locate somebody. Let's think about some mall. Okay, we are all at home. I don't know when it's going to get normal. So one day it will get normal. So you happen to go to a mall which is generally crowded, and you have this surveillance robots that are set throughout the mall, and you want to know or identify a kid who's missing. Okay, in that entire mall, it's let's say 5 6 floors. Okay, and in the areas I don't know, let's say it's as big as your city. Just giving a weird example. Okay. So to identify the kid who has been missing, you have your face recognition all done. Okay. These robots are all equipped enough to do a face recognition and revert back with the output. Okay, and it's again a big mall. There is a new store that is getting set up, and you want to convey that it's going a store is getting set up, and there are lots of goods that are coming in. So you can inform the appropriate robots saying it's crowded, to the person who's bringing the goods. It is please leave way to the passengers or the shoppers in that particular area. And if there are something to do with fire or some problem, you can alert the robots and thereby alert the people who are in that locality. Okay, so these things are like hmm, very important, and it would definitely come into place. It must be in place in some of the bigger cities. Yeah. Okay. So this is something, you might not have even thought about. Is there a CPS that's built in an escalator? Okay. So this is like, how do I keep stop wasting energy, okay, power, by stopping my escalators whenever there are no people around. Okay, it has to be used only when people are. This I'm sure most of you have ever used, right? So this is a CPS. Okay. Again, there is analytics here. You have to understand whether somebody is there or not around. So we'll move ahead on a few of the uh, domains and see how CPS is going to be used. AI is part of it. So, swarm robotics, any endoscopy could be done using these robots. These robots are just, you know, days are gone when, we all saw a robot movie which has the robot is a, it's like, 6 feet high, and you seem to think that a robot is a huge machine or something. So its days are gone. Anything that is automatic and does some data collection and comes back with an analytics is a robot. So here they're talking about very very small robots that could be put into your own system, into your body, and would get things done, whatever should be done. Okay. Um, Laparoscopic operations. Okay, these are also CPS. So remote surgeries are going to come out, and the world's first robotic heart surgery was recently performed by a doctor from a remote location using robotically controlled instruments. Okay. CPS will use the network capabilities to overcome geographical boundaries, enabling expert availability for treatment. So this is how smart healthcare is going to become. Smart factories. Okay. So this also I said you can do. See, shop floor, if you understand how a factory would look like, you will know the complexity of a shop. Okay, the shop floor is where the end product, okay, is being built. So, as the owner of the factory, you can walking through the entire facility and looking at what is happening, how it is happening. You can have your swarm robots installed everywhere, wherein you can see what how it is happening. Is there a maintenance that is needed? Is there anything that has to be looked upon? All these could be done just by having robots. Smart homes, we are already, we are seeing many things on this. Okay. So CPS can into uh, give a home which is even more comfortable, okay, even more cozy, uh, switching on AC even before you come back, preparing food even before you come back. All these would be part of CPS. Okay. Okay, so this is something on agriculture. Okay, here we are thinking about giving more knowledge or more, giving more information about the farmland when you are somewhere else. So you can do when operation could be done, okay, on a physical body. Why not you do farming somewhere else? This also could be done, and drones are going to play a very very vital role on finding out weeds, finding out things that are going to be of danger to the crops, and whatnot. How to understand the soil, all these things are part of, okay, CPS. So I am actually coming to the closure. We have seen what is CPS, and we have also seen AI and its impact on CPS. So thank you all. I presume that I at least um, a drop of knowledge that I have. So any questions you can please let me know. Anybody? To close, I think I have another 10-20 minutes. I to close with, I want to say an interesting incident about BMW. Okay, BMW cars, very famous, right? The BMW cars. BMW cars are being used a lot by uh, European countries. Okay, so it so happens that husband having a BMW, wife having a BMW, fine, that's all good, right? So what generally wives do is they just go um, shopping. They just housewives, okay, they drop kids in school, come back. Husbands go for work, they come back. Okay. It so happens that BMW had to um, spend a lot on spare parts insurance. Okay, so they were worried what has to be done, and because it's too much of money that's being spent on spare parts insurance money. Okay, so much of um, wear and tear happens in the cars. So they decided to do an analytics. Okay, it so happened. Okay, we are thinking that AI or machine learning is about lots of data, lots of very complex algorithms that are going to be in place and this that and this BMW car hired, or rather got in touch with an Indian company. I'm very proud to say that it's an Indian company. Okay, a very small company then. Okay. So, see, this is what is happening. So, can you do an analytics? So, even before they designed an machine learning algorithm or anything to be started with, they started with understanding what is the data. Okay, that's the crux actually. So, data is they gave the list of customers. Okay, so who all got or purchased a BMW car in the years, over years, and who all have been asking for spare parts, lots of, and predominantly on engines. So it so happened that um, Indian team was able to crack the issue in no time. So they were able to understand that it's because BMW engine was so designed in such a way that its efficiency gets improved as and when the car goes faster. Okay, the more it goes, the more efficient it becomes. Okay. The housewives, what they do is, the schools are very nearby, the shopping malls are nearby, so they go even before the engine heats up or gears up to the um, optimal or better efficient um, um, efficiency better efficiency, it just stops. Okay, so this becomes a big burden to the engine. So the health of the engine became very poor in a very short time. So they understand. So this is the power of data, is what I'm trying to say. Okay? With visualizations, they understood that this is how BMW has to work back, reverse engineer the engines that are going to be part of a person who's not going to drive a car. So today they have changed their um, design of the engines according to usage of the car. Okay, so when people would have thought what AI is going to do for BMW. Most of us would have thought, okay, in sales forecasting, right, or something to do on how recommendation engine, something like that. This kind of people will buy this kind of cars, but I'm talking about something which is which can not be even thought about, engines. Yeah, I'm done. Anything else that you want to know from me, I'll be very happy. And I'll be very happy if you give a feedback right away, something I can think of. Good, bad, worst, whatever. Very silent crowd is something that is very different in my sessions. I think this is the first ever session that nobody has spoken to me. Anyways, thank you, Shankari ma'am.
Ma'am, participants have their queries in chat box.
I don't see any.
No. Can you explain the difference between machine learning and artificial intelligence?
How come I'm not? Oh, this is comments, is it? Okay.
Yes,
Oh,
in that.
wow. I'm very sorry, guys. I didn't see this at all. So,
So many.
thank you.
Yes.
Thank you. Thank you. And nice to see somebody from Andaman. Nice. Very nice. Give me a couple of minutes. I'll just go through it. Hmm. Okay. Somebody from St. Britos. Okay. Oh, Port Blair. Ma'am, you have done a real good reach out. That's nice to see so many people from outside Tamil Nadu. Yeah. Oh, somebody from Odisha. That's nice. Okay. I'm very sorry. I thought, I've been talking to a crowd which is. Oh, I get the comments from the private. Okay. Okay. Tiruchendur. Oh, very nice. Okay. Mhm, mhm. Nice session. Thanks for that.
Ma'am, one
Mm.
question. Can we explain how artificial intelligence is used in music?
Very, very nice. Okay. See the slide which I had prepared had some very interesting stuff on speech. Okay. I mean audio. Artificial intelligence on music. You can today. Okay. Today, the power of AI is such that you can create a music album from a list of music chords that you just feed. That's the power of AI. Okay, music, and you can also have music according to your mood. The mood could be predicted from facial gestures, from your speech. Your phone could be so predictive that in a day's calls or the way you have been handling the phone, you could get to know how stressed you were in this day. You can get to know how stressed you were when you are talking to a person, when your
Ma,
tone
கதவு
gets
சாத்துமா போய்.
when your tone becomes at the verge of anger, you can get recommendations saying slow down your tone or mellow down your tone. So this is these are few applications that I'm saying. Any So somebody has asked when it would be used largely in agriculture sector. Mr. Raju, actually, um, any day, even today, you can use. See, what makes it difficult and what makes it uh, why there is a delay is see, first thing, even as computer science and engineers and practitioners, there are people who think AI is going to ruin their career. Okay, it's not like that. You should have definitely there should be human being to write those algorithms, to write those code. Okay, so without that, you cannot make anything happen. And in the consumer end, okay, the farmer should be uh, technically sound enough to accept that this machine is going to work. Remember from uh, the bullock carts or bulls plowing the farms, tractors came in. Okay, so tractors are still being used. So to make them understand that some drone can do a de-weeding better than a person who has been doing the de-weeding for centuries, it would take time for India. It's how you can bring. So it's like if you could bring the change in your farm, maybe the people who are alongside would take it. How I see it. Okay. And any other thing. Okay, machine learning and Sita Lakshmi. Machine learning is those are the algorithms that are used to classify or predict or do a recommendation. But when you're going to apply it on something, there comes your AI. Simply put, if you know something on machine learning, if you have a Python Jupyter notes, you have installed everything in Python, and you're ready. So you do a you know take the data, you scale it, transform it, fit, and do a model. So there ends your machine learning. So after doing this, you build a nice application that would be using this machine learning. That is your AI. Got it? Hmm, okay. Oh, I think I'm done. Your contacts, please, Sita Lakshmi. I'll be very happy if you contact me. Um, you can get my mobile number and email ID from Shankari ma'am. Yeah. Okay. Bhaskar, thanks for that comment. Excellent. Nice. I felt so bad, closing the session without any feedback. This is nice. Thank you. And I'll have to apologize. My system crashed and I couldn't give the PPT that I prepared predominantly for you. Sorry for that. But still, this session would also must have been, useful. I'm not sure how many of you know about CPS. So today you have learned something. Yeah.
Yes, ma'am. Ma'am, thank you so
Mhm.
much. I'm Kamakshi from Mohammed Satak Engineering
Yes.
College.
Okay.
So, a sincere thanks. I would like to take this opportunity to express my heartfelt thanks to our management and our principal sir for their motivation and support to conduct this FTP. My sincere thanks to you, ma'am, also, Dr. Poonkavithai, ma'am, for accepting our request and share your valuable knowledge with all of us. Thank you once again, ma'am. Once again, my heartfelt thanks to all the participants for their patience and their overall support. Kindly fill the feedback form and then you can leave. Ma'am, thank you, ma'am. Thank you so much, ma'am. You can leave, ma'am.
My pleasure. Thanks a lot. It's a honor to be here, part of this session. Ma'am, one request: if somebody is asking my contact number or email ID, please do not
Yes, ma'am.
hesitate. Please pass.
Yes,
Thank
ma'am.
you.
Yes, ma'am. Sure, ma'am. Sure.
Thank you.
Thank you, ma'am. Thank you so much. Participants, please fill your feedback form and then the session is over. For tomorrow, we have one more link. So for every day, we have a separate YouTube link. Today, there is some confusions in that. So sorry for the inconvenience. So we sent the guest link to you all. So sorry. So from tomorrow onwards, we will send for each and every day FDP. We have sent a separate link for you all. 80% attendance is mandatory to receive the certificate. At the end of all the sessions, we posted our feedback link at the end of the session. So thank you so much. Kindly join for all the days. Thank you.
And one more information, participants, kindly all of you join the WhatsApp group. Then only whatever the informations we are pausing, we can reach you. Okay? Thank you.
Shankari madam, why can't you share the WhatsApp link, the two WhatsApp links to here itself
Here itself. Okay, ma'am,
in the
sure.
chat box also? Okay,
Okay. Okay, we'll
fine.
share it.
You just share it.
All are get the link.
Yes, one more link. No. So the second link.
Okay, okay,
Yes.
sure.
Okay, fine, fine.
Any one link is enough. All of you get it, the link?
Yes, sure, ma'am. We will send
Okay.
the PPT as well as the phone number
It's
of the
available. It's available in
resource.
YouTube only. Okay, you can see at
Okay.
any time with our college name MSAJCE under. You can see our demo introductions to artificial intelligence.
Kindly subscribe the channel for further informations and then to attend the further FDP as well as the webinar.
Okay.
Okay.
Thank you, participants.
Thank you so much.